To solve this question, we should first recognize that we have some right triangles hiding within this quadrilateral. Here's what I mean. If we connect points B and D and label this side to have length x, we can see that we have a right triangle here. Since we have a right triangle, we can apply the Pythagorean theorem to get the following equation. We can now solve this equation for x to get x equals root 34. So the length of BD is equal to root 34. Now notice that we have a second right triangle. If we label side AB to have length y, we can apply the Pythagorean theorem here to get the following equation. We can now simplify our roots to get this, and now if we subtract 18 from both sides, we get y squared equals 16, which means y must equal 4. So we now know that y equals 4, which means the length AB is equal to 4. So as you can see, column A is equal to column B, which means our answer is C. Okay, our first piece of information tells us that these two lengths are equal. As such, we have an isosceles triangle here, so this other angle up here must also equal x. We also know that all three angles in this triangle must add to 180 degrees. So this third angle must be 180 minus 2x degrees. The second piece of information tells us that these two lengths are equal. So once again we have an isosceles triangle, and in this case these two angles are equal. Now since all three angles must add to 180 degrees, our two bottom angles here must add to 180 minus y degrees. Now since these two angles are equal, we know that each angle must be 180 minus y divided by 2 degrees. Finally, notice that this angle and this angle are angles opposite each other in an intersection. As such, these two angles must be equal. So we'll set them equal to each other in this equation, and now we'll solve this for y. First, we'll multiply both sides by 2, and now we'll subtract 180 from both sides. And finally, we'll multiply both sides of the equation by negative 1. So as you can see, the answer is D.
Okay, so we have here three cubes, or rather three cube-shaped aquariums. They're each 5 inches, each of their sides. So there's our cube. We have 3 of these guys, and therefore the total volume would be, well, s cubed or 5 cubed, and since there's 3 of these, we would end up getting 375. Now the water from here is being poured into a larger aquarium, but this aquarium only has to be filled, oops, that's anything but a cube. This larger aquarium only has to be filled to 50%. So therefore this could be 375 at the 50% mark, and meaning the total would be 750. But there is another interpretation. This is the largest possible aquarium given these constraints. The smallest possible one would be simply where 375 goes all the way up to the top. So we're dealing here with the range of 375 to 750. Now, with that said, to go from volume back to side, you simply take the cube root of that number. So you take the cube root of 375 and the cube root of 750. And that way we can find the range, and I would recommend using a calculator. The other approach is if you know your cubes, you would know that 7 cubed is equal to 343, and that 9 cubed is equal to 729. Now, I don't think this is the most important cube in the world, doesn't hurt, but 9 cubed, knowing that 729 is very helpful. In fact, you should know all of your cubes up to 1,000, arguably 7 being the one that's least common, but if you know all of them up to 10, then it makes this question a lot easier, because you can say, okay, well, 6.9 is too small because 6.9 cubed would be a little less than 343. Remember, our range is 375 at the bottom. So what about B, 8.4? Well, we can see that 750 is greater than 9, therefore 8.4 would be fine. But 9.5 is somewhere between 9 and 10, and 10 cubed is 1,000, so 9.5 would be somewhere in between, almost in the middle of 700 and 1,000. But 750 is only slightly greater than 729, therefore without really doing actual math, we can also figure out that the answer is B. And when I say actual math, without using the actual calculator.
Square ABCD has side length of 4. Point E is the midpoint of AC in the center of the semicircular arc from point F to point G. If the area of the shaded region is pi k minus 16, minus 16 of course is the area of the square, what is the value of k? All right, well, we have a few things to think about here. We're actually going to need a little more room, so we'll clear away the text. We know that this is 4, and so we know this is 2, this is 2, this is 4. Well, let's draw this line from E to C. Of course, that's a radius. And of course, we can do the Pythagorean theorem there. Radius squared equals 2 squared plus 4 squared. And so that's 4 plus 16 equals 20. We don't actually have to solve for r because we know that the area of the whole circle, area of the circle, would just be pi r squared. And so that's going to be pi times the value of r squared, which is 20 pi. That's the area of the entire circle, but what we have here is a semicircle. So the area of the semicircle would be half of that, 10 pi. So the whole semicircle would be 10 pi, and then 10 pi minus the square, 10 pi minus 16, would be the area of the shaded region. And so we see that k has to equal 10.
To solve this question, we need to know that the side opposite the largest angle in a triangle will be the longest side of that triangle. Now the problem here is that we do not know the measures of these two angles. So these two angles could be 46 degrees and 45 degrees, in which case this would be the largest angle, and the side opposite would be the longest side. So here we see that column A would be greater than column B. However, our two missing angles could be 90 degrees and 1 degree, in which case this would be our largest angle, and BC would be the longest side. This would make column B greater than column A. So since we cannot determine which column is greater, our answer must be D.
So this problem is really about digesting all this information and putting a diagram together, and that's probably what takes most of the time. So there's a circular courtyard, and there's a flagpole that stands. You don't have to have really pretty diagrams in the exam. So we're told that it has a 6-foot tall fence. So the fence also goes around like that. This is 6 foot. And a ladder is leaned against the fence from a point outside. So something like that. The ladder is leaning against the fence. So it's not only touching the fence, and then it's touching the flagpole. And that distance here is 10 feet. That's this piece of information. We're told that the base of the ladder is 9 feet away from the base of the fence. So that is 9 feet. These are all 90 degrees because these are all vertical. And the question is, what's the distance in feet between the base of the ladder and the base of the flagpole? So we're looking for that distance, x. Now, the key thing to note here is that these are similar triangles. You'll see both of these are 90 degrees. They share that as the common angle, whatever that is. And then this third angle would also be equal in a right triangle. So the ratio of the corresponding sides are the same. So that means that ratio of this, which is the height of this larger triangle, to the height of this the smaller triangle, 10 to 6, must be the same as that of the base of the larger triangle to that of the smaller. Actually, it's 9. So that's why it's important that you label it cleanly. So in this case, I can isolate x and reduce it, and I get 15. So the answer is D. So here we're given this equilateral triangle ABC, and we're told that the distance from point A, from this vertex, to the midpoint of BC is square root of 6. So this is going to be an altitude, meaning it's perpendicular to the base BC. So that distance is root 6. Now you'll see that root 6 is one of the answer choices. Now, if they tell us that a point P is inside the triangle and can be anywhere, question is, what are the possible distances between points A and P? So we know that if P was right here on the side BC, it would be square root of 6. But P could be inside as well. You can imagine rotating this perpendicular like this, that means we could have a point here that is of distance square root of 6. So that's acceptable. And you'll notice that square root of 6 exceeds all 4 of these values. And those could be points that are here on that same line, but closer to A. So we know that all 4 of these are acceptable. The question then is, what about the last 2? And that has to do with figuring out what the length of the side of this equilateral triangle is. I'm going to draw a new triangle here, and this goes back to the ratios that you need to know for an equilateral triangle. So we know this is square root of 6. If the side is S, then this is S over 2, because that altitude divides the equilateral triangle into 2 equal parts. And using the 30, 60, 90 ratios, we know that the altitude would be root 3 times that. So S over 2 times root 3. So that would give us the length of the side. So S would be 2 root 6 over root 3. I'm moving these terms here. That knocks out the root 6, will be left with root 2. So the side of the equilateral triangle is 2 root 2. And root 2 is about 1.4, so this number is approximately 2.8. So we know that distance between A and P, even if it's at this other corner here, has to be less than 2 root 2. Which, if you look at these two choices, they both exceed 2.8, or 2 root 2, I should say. So F and G are not possible. So the answers are A, B, C, D, and E.